Hey everyone. Gosh, you fix one fish finder and then everyone that's got one that doesn't work starts coming out of the woodwork. So today we're looking at a Lowrance LMS-337 DF. Something in the little rainbow sticker there. Yeah, I think it's a DF. Model does not turn on, and that's about it. The last couple that I've had have had water ingress, so I hope it's not a design feature on this sort of brand of unit whereby after so many years they just decide to leak. Yeah, it's pulling 0.01 10 milliamps at idle, and when you hit the power button nothing happens. So let's take a look. I see a lot of damage around the memory card slot usually, so we'll have a look at here first. That all looks pretty clean in there, so it's a good sign. It's a good starting point that there's nothing obvious there, that the card slots and all the other models have been pretty shocking. So around the edge we have a bunch of Torx screws, most of them with a coarse thread. One has a fine thread, and that came out of this side here, so make sure we get the right one back in the hole, and then as is common, 3 big plastic nuts on the connectors there, and then that loosens those, and off with the back. And that looks very clean. I don't think there's had any moisture in here at all, any water, so that's a really good start. Very good start. So do we start from the power button and work our way back, or do we start from the input and work our way forward? Both approaches can be as good as each other without having a circuit diagram. So this is our power connector here, coming in, likely regulator there. Do we have any switching regulators, or are they all linear? Got some inductors over here, but maybe some transistors on the back side. Oh yeah, I can see. Looks like a couple on the back side, so probably a switching regulator there. And yeah. Alright, I'm going to start with the power button, just make sure it's nothing simple, make sure that it's got an expected something voltage on there. It'll probably pull it to ground to tell the processor to turn on, or some power circuitry to start up as well. Okay, they just used a real old school fuse holder tacked down onto the board. It's got tape, so it's sitting upwards with tape holding it all in place. A bit of plastic sheet through here, which I think is nothing more than an anchoring point, perhaps, for the fuse holder, and the insulation tape holding it in place. That seems a little bit how you're doing, but we could check that fuse, I guess. Where there's a lot of hot glue in there as well. Alright, we'll check that fuse, and then we'll check the power button. Well, this is something. I don't know if this is a factory afterthought or if this has been repaired before, because there is Kapton tape. The Kapton tape here holding this white sheet, which I wouldn't have thought they'd put in from factory as it could be for an insulation purposes, because there is a high voltage coming out of the output to the transducer, but yeah, that fuse holder is definitely an afterthought. These two orange wires are coming down, and they come down to a surface mount fuse and are soldered directly on top of that. So either that fuse has blown once before and they've replaced it with a user serviceable part, or in the factory they realise that that isn't going to cut it. But no, there's no way they'd do that. Somebody's done that on purpose. Somebody has done that on purpose. So let's take a measurement there and we'll see what resistance we have. So we've got 0 ohms, so we know the fuse is intact, but jeepers, that's interesting. I wonder if the fuse blew, so someone went to the effort of putting another one in and then found out that it's still completely dead, but not to the point of blowing the fuse again. But it is, yeah, interesting, very interesting. Oh well, I'm going to move to the keypad and just see if I've got any power at the power button. I stand corrected. This cable, bunch of cables, has a number of red and black wires, and I'd actually picked the wrong one to start with. I was only powering the NMEA bus, which is fine, but not going to make this unit turn on. This end is the official power to the unit. It's interesting that this white wire is in the book written down as a external speaker connector. So I don't know why that was connected to ground, or if it's okay to have been connected to ground. There's no mention in the book that you should connect it to ground, so whether that's gone and damaged the speaker amplifier by dumping amplified audio to ground, maybe. But anyway, I'm not measuring a low resistance across positive and negative. However, when I connect the power, it wants to draw a large amount of current, more than 3 amps. It would probably just keep going if I left it on. I don't want to do that. It says to use a 3 amp fuse, so it's clearly pulling a lot more than it should. It's likely that perhaps then we're at the same problem that the original person had, so they've bypassed this fuse. Maybe they've put like a 10 amp fuse in there or something stupid. Maybe. So it's only rated 2 amp down on the board down there, which is interesting if that's our main fuse in, because it says to use an external 3 amp fuse. So the one inside, you'd want to protect what's inside first with an external fuse, because the end user can't really service this unit. So that seems a bit strange. It can't be our main fuse, but you know, I don't know, we'll find out. What about, let's just take a measurement to that fuse from the positive lead and just see if that is. Ah, it is. Okay, so this seems to be our main fuse in, and while the book says use an external 3 amp fuse, the internal one's only 2 amps. So if you ever get to the point of blowing the external one, the internal one's probably already gone and then you have to send it in for service anyway. Yeah, unless of course the internal one is some kind of slow blowing fuse so that the external one can be used. However, we need to keep looking. Something's causing, and it's only causing an overload when power's applied. As I said, I've got a high resistance on the line going in, so we need to trace the circuit through now, find out where that goes to, and find out what's pulling it down. The screws I've used are not magnetic, possibly being marine, maybe they're all stainless steel. There's only 4 that I can see holding the backboard on. Then we've got a plug down here which goes down to the SD card reader slot, and then we've got our backlight connector up here, so slide that out, and then another little plug which goes up to something on top, which is probably the GPS antenna, and then a flex, being careful to wiggle that out without damaging it, and it looks in pretty good condition. And that, we've got a soldered on ground wire down here. Let's get rid of that. I know I keep complaining about my lighting, but at the moment I have no real urgent need to do anything about it, and I'm using one bench supply to run the camera, which is the one so then I need the other one for my lighting to run everything else. Now I could run the lights at 12 volts, just means the fan's got to be running all the time. There's a big ground plane on here, so I really did use the wrong size tip for this. That will make do. I'll have to do that a bit better with when I put it back on. A bigger tip. Okay, it's looks like we've got a flex on the underside there. Goes to the LCD. They give us a little bit of slack to work with, which is nice. And they're just going to pop up a style retainer. Here we go. They're all clean looking on the flex there, so that's a good. Yeah, definitely no sign of liquid getting in this one. Oh, okay, where am I going to stick that? Bench space is running low. Right. On the underside, yeah, a little bit of residue, manufacturing residue. I think that's just flux, hasn't been fully cleaned off, but again, very clean looking. So now we need to follow where our fuse attaches. Well, we need to follow through that input circuitry down there. Yeah, I don't think we're looking up here. The fuse is mounted up there, which threw me for a bit till I found out that that's actually those. So we're looking down around the bottom, I think. And possibly there's a surface mount IC there, which has a number of MCP 2551, I think. Possibly. We'll get a closer look at that. Here's our black and red input. But I am concerned about that speaker wire having been grounded. It could be that the audio amp is shorted and that's what's pulling everything down, but we'll work our way there. We've got, so it goes through the fuse and through this diode, which will be a reverse polarity protection diode. There's another big diode beside it. Maybe we just check those and see if they look alright. Have our meter in diode mode, and positive on the anode, negative on the cathode. We've got half a volt drop, so that one is okay. And that one beside it is also okay. So it goes through there, and then this inductor, and then it disappears to the other side. Hopefully there's no internal traces that can lose things in, but so that comes out here. It then goes through a resistor of very low resistance. It could even be a current shunt. They may be monitoring input current. There is 1, 2, 3 in parallel. Maybe it's only used to get the power across this trace that runs underneath, perhaps. Maybe it's not current shunt. They're just bridging a gap. And from there it goes to nothing there. It may go back through to the other side of the board now. Oh no, there could be a pin sticking through there. What's that? Oh, that's that. Is that the cap? Yeah. There's a cap, input cap there. That's that cap there. So it goes to there, and then I guarantee you there'll be a trace under that cap. So we're going to have to take the cap off to find out where everything's going. But we'll measure across the cap as well and just see what resistance is there. So our positive is on top side. $57 ohms. Okay, so that is a little low. Why didn't I measure that on the input? Probably because it was going through that diode. So there we go, 57 ohms, and I would have thought that would be too high to get the current we're seeing. So something else must be turning on and pulling it down. Let's see what a diode measurement across that cap may look like. Yeah, it's coming up as a very, very low, but then it is. Okay. In hindsight, that was kind of pointless, but so we need to find out where that positive line's going. Guess we'll have to pull the cap out. The old fuse in the holder is a 4 amp. That's a good amp above the external recommendation, and a good 2 amps above its own internal recommendation. So this thing's not got much of a chance, although I'm surprised that didn't pop. If that's their method of repairing this and then it stops working, they would have had it wired up. Maybe they had a 3 amp on the external that kept blowing and that's what's been saving it. That's all I can think of. They actually put the right fuse on the outside wire. That's probably it. But I'm going to have to cut away the silicon to get that cap off to find out where and diddly that line goes to. Alright, so I couldn't film this part on account of my battery being crap, and I had to use the other power supply to run, to do the test. So I popped it on a current limit of about half an amp, and away it went. And the only thing protesting and getting hot is this. So we need to find out, take that off and find out what it is, and then do a measurement on it to make sure it's happy. But it's the only thing getting warm. Whether that's because it is faulty and is shorting the line to ground, or whether it's because something further down the line is pulling power through this. But I would imagine I could not feel heat anywhere else on the board, just that one part there. So let's look into that a bit further. Let's take a measurement while it's in circuit, and we'll just see if we can find out if it is directly connected to battery, which comes in here, and so that is connected to battery. This pin is definitely going to ground, and I will prove that by finding ground, which is as we know, there's ground, the other side of the capacitor here. So those two are definitely connected through, and if we take a measurement from, now it's either the base or the gate, I don't know yet, and we've got, okay, so base to positive is looking normal, and normal that way, but a very low resistance from emitter collector or drain and source. So still, because that was getting hot, it's likely that's failed. I'm going to take it off the board, check it again out of circuit, find out a data sheet, find out what it is, and hopefully, it's interesting though being shorted through, it must be, I wonder what that's actually doing. It doesn't look like it's doing any switching, but we can never tell. And this right here I've noticed, look at that, look at all the bubbled up on the insulation there. So I wonder instead of switching across this, it's just been sitting there shorted and getting stinking hot, eh? We might find if it is connected to there, that is no longer going to be working. It's probably boiled all the varnish off and shorted the turns together. That is not ideal. Bugger. Let's take a measurement there and just see if it's going across to that transformer. It could be end of the game for this one. Oh dear. That's one winding. That's a winding. Yeah, I'm not holding much confidence on this one. Shit. Well, part of. I need to get a bigger nozzle for my hot air gun. I actually need a new hot air gun. Really, get something with a bit more grunt and a bit better airflow. So we're checking across our gate and drain. Yeah, she's a popped. That's no good at all. Gate to collector and gate to drain, gate to source look alright. Okay, let's look at the data sheet just for the sake of it. And we're looking at, it's got 519 with the on in a circle. I think on semiconductor, that's a company, isn't it? So 519, then there's 55 and then 094. So we'll see what we can find. So the markings that were needed in the end were the last two, the 55 and the 094, and it is a 60 volt 12 amp N channel MOSFET. Yeah, that's about it. Took a little bit of googling, not too much luckily. The first number, which was the 519, according to this section down here, is the device, the assembly location. So not always the first string of characters is the part number. Okay, so now we know what we're dealing with. We can find something to put in there, cross our fingers that that molten transformer is not totally stuffed, but there is every chance that it is. And see what happens. I mean, got nothing to lose. I've got no idea where I'll find one of those transformers from. But I could probably put in the code on the top perhaps and see if they are available. Let's have a look. So what do we got? 029-0110-02. No. Interesting, it brought up a Lowrance GPS page. 3 pins, one side, 2 pins out, bottom, opposite, transformer, yellow tape. Oh, look at that. Interesting. Maybe this is a common problem. This is going to go to a forum. Let's see what these guys say. I have a mini transformer mounted on the PCB. I have removed it. I need a suitable replacement. Interesting. This might be a common problem. Someone's got a link to a G-Site Technologies page, which has GCI on the label, so that's, yeah, possibly it. This could be a common failure. Maybe the transformer goes short and then blows the FET. Yeah, maybe. This looks promising. There's a picture of a transformer on the main page, so it must be the correct G-Site Technologies. So pop in our product code and go to hit search. And what do we get? Nothing. Absolutely nothing. Well, unfortunately, it doesn't look good. I can't find one anywhere. Even looked on eBay. Yeah, unless you can get hold of another completely destroyed unit you can maybe salvage parts from. But I thought I'd just look at it a bit closer and think about the vicinity of everything. And what I'm thinking is this is the backlight power supply. So here we have, well, here's the step-up transformer, and this looks like a FET that's switching across the primary of that. There's a couple of capacitors there, and it's all in the vicinity of this, which I think is taking 12 volts, stepping it up through here to maybe double, or what have you, which then allows this to generate an even higher voltage across here. So to prove that, I'm going to leave the transistor off and stick power on it, and if it turns on, I'm picking it will, and if I'm right, we'll have an image with no backlight. This is a good thing because we could go ahead and remove the existing backlight and perhaps replace it with a string of LEDs. At least the whole thing might actually be usable again, but I don't see finding a replacement transformer really an option at this stage. There's another similar one on the left, but it's a different number, so it's going to be a different voltage, and that I'm pretty sure is for the sonar transducer anyway, so let's see what happens. Okay, what a horrible position. If this works, hopefully you might see something. So she's all hooked up. Hit the power button. Oh, there we go. You can kind of even see the colour on that. And who needs a backlight? That's clear as daylight, as long as the sun's out. No, actually that's really quite dim in real life. But there we go. That's the backlight circuit, of course, and now we need to find a workaround. My camera is hugely unreliable. So, back of the LCD, just taken the cover plate off. That happened in the last corrupt video. But what they do is, there's the assembly. It's about 10mm thick. It's quite a decent setup, and they double side tape that to the glass, or to a glass plate, fairly solid glass plate, which is then siliconed to the front of the housing for water tightness. So the only way to get that out is to either break the water seal on the case or try and pull the LCD off the glass. You can sort of see the two sections down there, even though it's bright as hell. There's the glass plate. She's a good probably 5mm thick, and then there's the assembly there, which is about another maybe 8 to 10mm thick. So quite robust. There's a bit of weight to it with the glass that thick. So I'd probably rather try and pull the LCD off the glass so that it maintains the water seal, and then it won't matter too much if we have an issue getting that back onto the glass, but at least we can clean the glass on the back and apply new tape and whatnot. A pain in the ass, but that's probably all there is to it. Now if you look carefully, there's clips all the way around the side. We have one screw in this side for the earth cable, but everything else is clipped, and the lower section is wider than the other section, so this is sitting inside this metal frame. We should probably pull this out and leave the frame stuck to the glass, and that would save a whole lot of headaches. Because I mean, if you start getting in there and prying and twisting and trying to dig out the tape and whatnot, you're going to end up cracking the LCD, guaranteed. Or the front glass if you're totally unlucky. But yeah, I think we're going to have a go at that. We're going to pull off all this copper foil and see if we can't lift out the whole assembly from the back. It would certainly make a whole lot more sense. A large one along the flex I'm just rolling up, and I'm going to leave stuck to the flex. You can roll it back down, whatever EMI shielding that's providing. Get that screw out of the side. Along with its little bit of wire. And see if we can't separate the screen. So, the one clip on the side, one down here. And you want to, what I'm doing is I'm gently pulling the bottom frame away and then lifting to get the clip clear from the hole that it sits into. There's none along the flex side, so we'll come around to the top side. Got a bit of tape holding the redundant cable for the fluoro tube. There's another clip down in here. There we go, popping up. There's another clip there, which has sort of come up with the last one, so we can dig in and lift up that one, maybe. Of course, if you, like I've just done, if you pull hard enough, it's going to bend this frame out anyway. It could be another way to do it, just bend the frame out. It's very soft metal, then straighten it all back up before you put it together, so that she all clips back in. That's mostly free now, so we should be able to pull it out, if I'm correct. It seemed to want to come from this side a lot freer, so I wonder if we can encourage it with the cable for the tube. Give it a bit of a tug. I think there's something going on down the bottom end where the ribbon flex cable goes in, but I'm not entirely sure what. So there is some tape under here. You can hear it letting go as you lift up on it, but I don't want to put too much flex on it for risking cracking the LCD. Uh-oh. That might not be good. What did I just do? Okay, well, it's done now, whatever I just did. Let's see if we can find... Okay, so I don't think I've damaged it. There's some tape holding this section that I'm lifting up is actually the backlight and diffuser section, and I believe I've just pulled it away from the LCD itself. So for some reason the LCD is fused to the front section. So I haven't noticed that the flex wanted to move, so there's a plastic cover that goes over the flex. I've just lifted that, and I'm going to get that out of the way to allow it to move where it wants to go. And then I think that's going to stay behind, and the back section's going to lift out like this. Very slowly and gently, and I've got the bloody backlight cable hooked up like that. Woo! So our LCD is still intact. What I thought I'd done before is I could see down the edge, down this edge, I could see this green section, and I thought maybe I'd pulled the flex off of the LCD. But no, we're alright, it's just some double-sided tape that was bonding to Now, was it the LCD or was it the front frame? I'm not sure because the tape's been left behind on here. Whatever. We're in! Okay, so here we can see the diffuser material, and it's I guess it's a sort of a thick unit. It might give us a bit of room to work with when mounting some LEDs. LED strip, it's going to have to be surface mount. So we'll just start by popping some more clips along the side here. Got that open. There's some down the side as well. That one there. Eventually, once you've let a couple go, everything seems to fall out nice and easily. Speaking of fall out, we probably don't want this to fall out. We want to do it gently in case all of these little clear sections, there's probably a whole stack of them and you don't want to get them all over the place. So, a bit of a wiggle, another clip release. Yeah. Okay. Alright, it seems to be all together. Of course, we know the top is where the cable comes out. There's a little cutout there for the cable and a cutout in the shield, so we know which way's up. And there you go, as you can see, the sheets there. Looks like it all wants to fall out. No, there we go, that wants to fall out. Okay, so we have a plastic section on the back, which is going to come out with the fluoro tube in it. Just lift that out, and then we have the sheets. There's a few sheets there of plastic for the diffuser, so we're going to leave those alone because I don't want them to come out. And there's our plastic, and it's got two tubes in this one. In fact, there's 3 tubes in this one. It might even have 3. There's one down here, and then something along the bottom, so it may have 3 tubes. I would probably try and stick an LED strip up the sides at least. I may not need anything along the bottom. That's another tube. In fact, no, it's one long U-shaped tube. That's pretty neat. One U-shaped tube. Just thinking about it, maybe I should find a universal CCFL driver and leave the tube in there. I know there was a brightness control in this, but we could set it at just one full level or whatever and leave it. Might be easier to do that, because that'll run off a 12 volt input instead of trying to mess around with LED. Decisions. I better make them before I go too far. Let's see what's available for a driver. So what if I took something like this out of a laptop screen and see if I can make that work? I'm sure it can't be that difficult. I know there's a bunch of wires going to it though. Must be doing some fancy control for the brightness of it perhaps. But there's going to be a power, a ground, and at least an enable. We can only try. Might save a lot of headaches. We could probably still fit an LED strip in there, but this would be a lot simpler. And I know there's universal driver boards available, but I want it to do it now. I don't want to wait 3 weeks to get one from China. And the only one local that I can find is a 2 tube driver. Problem with that is if it doesn't see a load on the other connector, it will probably shut down, so that'd be useless. So the driver on this board is it's basically a single chip solution by the look of it. There's no driver FETs, I think it's all built in. It's a MP-101B cold cathode driver. And if we have a look here, it's good for 25 volts in. At most, I wonder, yeah, there's not going to be another step up inside the laptop. It's going to run, it's going to do its own thing. So a 1 watt power dissipation and recommended operating conditions 6 to 23 volts, so can certainly do it on 12. And we have pin 5 is enabled by the look of it, EN, and what else have we got there? Let's have a look. Pin description. Oh, we have an analog dimming. Pin 1, BR analog dimming. Current feedback, sense, that's fine. Hopefully that'll just work and it won't think it's no current being a smaller tube, hopefully. Test and burst mode dimming, interesting. Burst oscillator timing. Chip enabled, do not float, must be connected. Otherwise it'd probably be flickering like crazy. Power supply in, ground. Okay, so there's only possibly one line that's used for dimming control. All those other wires there, yeah, maybe they're a bit redundant. I don't think there's any sort of digital conversations going on with this thing, so we'll run with that. Okay, for an application, just reading here, for an application with either analog mode or no dimming, connect the BOSC pin, short it to analog ground. So I think we'll do that. We'll go for maximum brightness. I mean, when you're on a boat, you're out in the sun anyway, so you want to be able to see what's going on if you've got a lot of sun on it. And given the age of it, I don't think anyone's going to care. It has PWM option for dimming, and it can be adjustable with an analog input of 0 to 1.9 volts by the look of it. So, well, I suppose I could find a valid resistor value to get a, instead of running full brightness. But then, hey, you know, what's the tube life expectancy, huh? I don't know if full brightness wears out any quicker than half brightness. I suppose it would. Open lamp. Detect open lamp. No. Okay, let's make a note. Enable voltage 0 to 5 volts. We're going to need to find a 5 volt, and I don't see that being a problem. There should be 5 volts on the board somewhere, and only when turned on, because at the moment it's going to have 12 volts as long as the unit's connected to the battery. But I would hope they have an isolation switch separately as well. But yeah, I don't know, what does this give us? A idle current off in the off state? Probably doesn't matter. Okay, here's a pretty quick and dirty setup. So I've figured out they've used the red and orange for negative and brown and black for positive, which doesn't really mean a lot to you guys because you've got no idea what model Asus laptop this came from. Anyhow, yeah, green is our enable, and I've got a 5 volt rig hooked up here, and we're on 12 volts in. And if I go chuck on our ground, and I should probably see, make sure we got 5 coming out of there before I do anything. Just knock you all over the place. Yeah, we got 5 volts coming out of there. So in theory, I should be able to tap the green wire on that output and we should get a light up. So if I take some of the glare away from the panel, There we go. And we should be able to see if we are indeed gonna work, or maybe we're gonna have to alter the dimming circuit, which looks like it's set up for pulse width modulation. And look at that, nothing. So I may need to alter the dimming circuit. It's probably expecting something. Stand by. Okay, so I've connected our pin 3 to the A ground pin, pin 20, as the datasheet said you need to do if you want it to be running full brightness. So we will try again and see if this will work. So I've got my 5-volt rig hooked up off the 12-volt line, and we're watching the panel here to see if it lights up. So I'm going to touch the 5-volt power panel on line. Look at that. Hey, excellent. So that's going to be a whole lot easier than using retrofitted LEDs. That's for sure. Alright, now I need to find where on the main board we can have a 5-volt rail that comes off when things running, and then find a way to tidily mount this driver in the case there. Well, this might be quite perfect. Here's the original connector, and if I line that up with that, then the length of the board is just mates with the side of the PCB. So this is going to fit inside the case quite nicely. I'll probably put some foam padding or something underneath that. I might even get tricky and make a little metal bracket to come off the screw post here and mount it to the screw hole here, just for a bit of extra stability and ensured grounding, and we'll see what happens. But now I need to find a power source. We know our 12-volt source comes in through this inductor, so I'm going to tap off that inductor. But I also need a 0 to 5 volt, it said, for the activate on the chip enable. Now I've got this much cable left. I'm going to have to attach some to the power cables to extend them over, unfortunately, but unless there's 12 volts on here somewhere, I will double check that, because if I could take it all off from over here, because these caps look like 4.7 volts, so I'm picking this as a 3 volt line, and I'll be able to tap off that too for the backlight enable. So maybe I'll be able to take all of it off here. There's a big diode there, so I'm going to check that we don't have 12 volts coming in through there as a good source, and there's plenty of spots to ground it on. So I'll get probing. Try and get the meter in the shot there with the unit on. I've got my negative meter lead over at the power lead going in, so it just keeps things clear. And I will check on the end of this diode. And that's only 5 volts there. Well, that's good, because I can use that as a 5 volt point. I think, if I'm right, this is probably 3.3, if there's anything there at all. No, it's 5.3. Yeah, okay. Alright. 5 volts. That's fine. Okay, I'm going to tap off the end of that diode. I am going to put the scope on it and make sure it's not the end of a switching inductor that has a whole lot of noise on it. I don't really need that to upset everything, but it's 5 volts there. If it is switching, it's probably, yeah. Okay, cool. So there's 5, and of course our 12 on the end of the inductor there, which is 11. My meter scale is a bit off. And just for a closer look for you there, there's the diode I was talking about. It has 12 volts on the other end. Sorry, 5 volts on the other end, and these caps all have 5 volts on them. Yeah, that's right. I said I was going to see if I could find 12 volts in this area. This is obviously switching 12 down to 5. So I wonder what's on the other side of there. if I just check here, what's that? Looks like an inductor. That's got 12 volts on it. Oh yeah, might be able to use that. Of course, these devices are probably designed to run up to maybe 18, maybe, I'd have to look at the book, but certainly you're certainly 14, 15 max from a charging circuit on for the boat battery. Okay, well, I'll inspect this here and just see if that's going to be a suitable 12 volt line. I wouldn't want to drag down. I'd rather have it be on the main line, and actually then I can be sure it's got enough current capacity. Yeah. Alrighty, we are wired. I did run over to the inductor in the middle here. It was the best choice to make sure I had enough power, although I don't think it uses a lot of power. The wires that originally go to it are extremely fine, but that will be okay. I've tapped off the end of this diode for the 5 volt, and I have just and beside there's some unmasked line through there where they probably intended to put on a metal shield and never did, and I've just connected the ground, soldered that to that line, and I guess, yeah, we're ready to try it. I'm not going to stick it permanently into place, just in case I have to let it run for a little bit and make sure it is going to stay running, but I don't want to stick it down in case I have to work on this board. I can take it off and put it under the microscope, make it a lot easier. So we'll flip it over and connect some power to it, eh? Right, well, that failed miserably. So yeah, I know I said I'd check the scope and I didn't, so I should have. Turns out it was a switched side 5 volts. It was a lot worse off than 5 volts, but anyway, this regulator down here is a solid 3, so I'm gonna hook it up to that and we'll see if that works. Okay, here we go. Whoa! Look at that. You'd never know it wasn't the original. Here we go. It is now charting unknown position. Okay, no GPS. I'm not sure if this has built-in GPS or not, this particular model. But there we have it. One modified laptop CCFL driver. Yeah. I will have to leave this running for a bit, make sure it's going to keep running, and yeah, if it does, you won't hear from me. If it doesn't, I'll come back with another solution for you. But there you go, a little bit of research and thought, and you can repurpose anything for anything else almost. I hope that was useful for you. It might save you a headache trying to fit LEDs around the screen. Yeah, I think there may be a few of these out there with that problem. If someone else had the same burnt out transformer, it could be a known issue with this model. So I may have to look into finding a decent source of single output CCFL drivers. But there we go. Thanks for watching.